right into our discussion today. My name is Alex. I am from Pittsburgh. I've been at HEICO for about 20 years now. I started as employee number 4 or 5. Now in our Pittsburgh office, we have over 150 people. So it's amazing to be part of the super cycle. And today, I really want to focus on some interesting conversations for us as a supplier to be involved in, but also some really important topics, I think, for our grid as a whole. And as a supplier, we're uniquely positioned to try to help more than just at the RFQ stage and delivering equipment on time and all the normal stuff that comes with a PO for heavy electrical equipment. I'm going to go through an overview on us as HEICO, a little bit of comparison in 345 and 765. That's actually a derivative topic that we were invited to provide for ERCOT, which was a unique invitation. Some of the cost variability that we saw between those two things, and part of why we were invited in the first place was to help ERCOT as a system operator make a very important pinch point decision for them in their future of the Texas grid. Some of the things that feed into the kind of critical components, availability, some market pressures. We want to talk a little bit on the market trend in general, and also some of our other products like 800 kV and some of the other mega trench projects within MISO. I'd like to keep this conversational. I realize we have a lot of key stakeholders in the area. I'm very interested to hear what your thoughts are on the information I'm sharing. Also probably have some questions for you as we go along. We have about an hour, so please feel free to interrupt, throw something, scream, whatever, if you have a question. Thank you. So HEICO America, HEICO is an acronym for Hyosung Corporation. This is a kind of complicated org chart for our company, but it's very important. We're a Korean heritage organization. Hyosung as a whole is a $15 billion a year company that does everything from spandex to ATM machines and power systems equipment where Gigi and I work. As we've grown here in the U.S., Hyosung has grown its interest in being more positioned in the U.S. market and more focused on being a U.S. corporation. So that's an interesting opportunity for me, having started as a regional sales guy selling transformers to find folks like you guys. We are a member of Hyosung Heavy Industries Corporation. Under that branch, we have Hyosung HEICO, which is our Memphis, Tennessee transformer manufacturing location. Some of you might know that as a Mitsubishi transformer plant that we acquired. My office is in Pittsburgh, Pennsylvania, HEICO America, kind of where we all got started. Big reason for that location is the heritage that Westinghouse left us, and a lot of the brain trust that was still in that area after Westinghouse had exited their T&D business and sold those assets to ABB. We also have an office on the West Coast, and we also have a service center in Greensburg, Pennsylvania, which is mainly focused on our switchgear products. For those of you that have traveled for circuit breakers, you know that that's kind of mecca, and pretty much every major manufacturer is in that area. So yeah, it's a great business, a great company. I'm not really here to pitch HEICO as a sales guy today so much, but I think it's important that you understand where we're talking about in our organization a little bit. We do sell power transformers and shunt reactors all the way up to 765 for multiple factories. We also have HVGIS 72 to 800 kV as well, and circuit breakers within that same realm. New entrant for us, and really one that's gaining a lot of traction, is FACTS, Flexible AC Transmission Systems, which is growing leaps and bounds. We have customers that we haven't dreamed would be interested in such an animal, but really the drive behind AI and also re-onshoring for manufacturing and exploration efforts like in the Permian Basin for ERCOT have really driven system advancements and stresses that we haven't seen before. So customers are really having to look at things like HVDC, MVDC, and different fact solutions like STATCOM way more heavily. We also serve the market with medium voltage GIS. We have a product called DICE, which is dry air, doesn't use any SF6, very unique product that's used widely throughout South Korea. Very, very popular, and it's gaining a lot of traction here in the US, especially with utilities in regions like California and the Northeast, where there's a lot of sensitivities to using sulfur hexafluoride. Another big growth area for us as a company is we now offer full engineering, procurement, and turnkey projects. So we found that that was a necessary kind of evil to be in the EPC business if we were going to sell turnkey solutions like VAX. But we've done some really big, cool projects that are substations that honestly I never dreamed we would be involved in. Things like the HQ2 substation in Washington, D.C. that feeds the Pentagon. Also, the substation actually feeds the White House. So some very exciting high-end opportunities have kind of grown our turnkey business and really being half of our portfolio. I'm going to ask Gigi to come up and talk a little bit about our Memphis facility. Gigi's local to that area and a key team member for us in our sales team.
Thank you. So my name is Gigi Campbell. I'm the Senior Sales Manager for HEICO America. So I've been in this facility for 8 years. So the original owner is Mitsubishi. So I actually watched the 765 kV. Actually, the very first one in USA, the last 20 years. In domestically manufactured in USA, that's the one. It was my order, my project, and I see how this facility from the shell type, that's a different technology before, and transited to the core type transformer. So my experience with that kind of EHV, it's a very high voltage transformers. It's very important you have a domestic manufacturing, and especially such a big country, we have to have the domestic manufacturing. So with the 765 kV, this is, you see our facility, it's a very high ceiling. You need a very big, the capability to pick up the active parts, the core and the coil. So those are the very heavy things. You have to have a very good engineering process, manufacturing process, and most important is the management process. How you lead your workers, how you manage your process, and the second thing is the testing. The testing capacity for 765 kV, actually you have to have those capacitors, generator ready for almost 1000 kV. So we are one of the few can test up to 1100 kV in USA, right? So you have the testing capability, you can manufacture this transformer, or any issues you wanna testing, verify with the transformer that this facility is available. So after you manufacturing the transformer, the site needed. So I think a lot of utility people here, you know, the transportation. With this facility, we manufacture 750 MVA, single phase, 765 kV. That's without any oil. That's 400,000 pounds. With the oil, everything. I don't remember it was like how much. I forgot the exact number. But with that kind of giant, with the big dimensions, you need a good transportation. So if you have domestic, and like a Memphis location, it's in the center of the USA. And we have all the railroad access come here. And you see the back of the factory? That's the river, right? So anything overweight, you can put on a barge, you can put on the rail. It's a very easy access. And the shorter distance is you limit all the risks for transportation. So for example, right now, ERCOT market in Texas, they want a 765 kV. It's already approved. The West Texas, go. they just gonna do 765 kV. They need those substations, they need those transformers. So think about it, if you have a from Memphis to West Texas, so probably just how many, 15 hours, 20 hours within, you drive there, you can get it done. So, but if you ship from overseas, right, you have to go through ocean shipping first. I don't know if you guys have deal with any overseas transformer. Some of those vessels, sometimes it's like 90 degrees. Think about it, you'll have a 765 kV, that big giant, like 90 degrees on the ocean, then come back, right? Those are risks is there. So the second one is inland shipping. Inland shipping, you deal with all those like all the rails, and you have to have a special rail cart. It's just a risk. Too many risks you need to manage. And nowadays, the transportation, supply chain, all those the crisis, and challenge us, challenge our our knowledge, and challenge our team, manage all those threats. So you have a domestic facility, it's very important to supply your people, supply your team. So after that, deliver to the site, there's another thing, is the service. There's a factory, when I was there, 150 people. So we have all those engineers, designing, procurement people there. So today, with HYCO, this is a facility, 400 employees, 400 people, 400 happy families. And we have the largest engineering team based in Memphis. It's over 20 engineers. Those electrical engineers, they can design the transformers right there. If you have any issues, like I have any questions, I walk across the hallway. I can just discuss with my engineers. Then we have mechanical engineers. So like this Saturday, the past Saturday, I have a call from utility, their transformer on fire. They said, oh, Gigi, help. We're gonna replace with a HYCO transformer. We wanna use your transformer replace on the foundation. Can you ask your people to check the transformer foundation fit our foundation? So I grab a call Saturday, call my mechanical engineer manager. He answered right away. He even drew a picture how you do is loading things and get it done. The customer sent it like a big font letter to all our managers, thank you. And we also teach them step by step how you testing a transformer, how to get your standing right for SFRA data. So this is very important because all our engineers are here, all your managers are here, you don't want to deal with the issue. You buy something, you want to get it done, right? So Saturday, no one bother you, or even bother you can call Gigi. But my phone number I don't want to share right now. So you can call him later for some reason. Okay. So the another thing is training. We have so many young engineers. I see young engineers here. So those are, you guys are the future for this country. Right? I come all the way from China for USA. This is probably the best country, the best career I ever had. So how we can make this country better? So we want to give you the training. All the knowledge I absorbed, I learned, we want to share with you. We need the power. Our generation here, a young generation here, we need to give the enough, the good support, the good power quality for this country, for our customers. Right? So I personally, actually Alex and I give 80 engineers, nuclear engineers, a training in our facility. It's all free. We don't want to charge anything, but we want to support. We come here, we have a facility here. We want you to see, come to our factory. Whatever you experience on the site, you see the factory, you immediately understand why it triggered the issue at the site. So this is what our offering here for you guys. And the most important is all those things. The 765 right now is experienced actually the crisis for the supply chain. And we also need your help to tell us your demand. What you forecasting? What seems the most challenging to you? We want your feedback to us so we can figure out a good solution for you. Thank you.
Yeah, thank you. And Gigi mentioned a lot of really great points about the company and our transformer business. Appreciate that very much. The Memphis facility was at an inflection point. So we purchased this from Mitsubishi in February of 2020. Does that ring a bell for anybody? What happened next? Yeah. So we were met with COVID almost immediately. And transformers as a product are extremely labor intensive. It's more of an art than it is a manufacturing process in many ways. Supply chain is very critical, and that was very constrained during COVID. So it put us as a manufacturer under a lot of very unique pressures. Usually when you see an entrant come into the market for power transformers like Hyundai, FSEC, I could go through a list of a number of other names. You kind of expect to see a 10-year kind of pain point for them, and yes, they're going to make transformers, and they probably will be larger and larger, and we'll have less and less failures. And honestly, we were sort of anticipating the same for ourselves. But just like heat and cold can make a diamond, COVID and transformer supply chain constraints can make a great transformer facility much quicker. I truly believe that all of those pressures at the same time, and being able to get people in for training, be able to get the resources for the equipment itself to make the raw materials really pushed us in all the right directions. It was not fun while we were going through it, and I'm sure many of you experienced the same thing with everything that you purchased, but it really did make us a much stronger supplier. So now, that day to this, we're seeing a market that is hungry for power. A lot of that is driven by growth in many markets, from EVs to renewable energy, but mainly AI data centers. And a lot of investment is going to take place for ultra high voltage. So our company was at an inflection point. In South Korea, we make large power transformers all day long. We make medium power transformers all day long. But what were we going to do with this facility? We really needed to make a conscious business decision. A lot of forecasting, a lot of customer feedback was involved in if we were going to make sub-transmission or transmission class-ish medium and medium large units, or if we were really going to go after the much larger business at hand. And specifically ERCOT, MISO, PJM, a lot of 765 and 345 kV growth is what drove us to go in the direction of making large power transformers right here in the US and bringing that technology back to America. So we're very excited about it. And so much so that we've just announced a big expansion for the facility. I'm going to talk about that in a minute too. But there are a lot of challenges that come along with that. Supply chain misalignment. I'm sure you guys are familiar with all the issues if you're dealing with transformers. I heard somebody talk about breaker lead times earlier. There's a lot of similar components there, at least as far as the insulators and bushings are concerned, or at least the supply chain for those. We're seeing a lot of tariff and global taxation uncertainty. So we really had to drive some strategic responses and diversify our supply base that we have here in the United States. We're looking for more and more localization in U.S. suppliers. The truth of the matter is, a key ingredient in power transformers is grain-oriented electrical steel, right? It's not even available really here in the United States. There's one supplier that makes it, and they satisfy less than 3% of the market requirement for it. That's been identified by DOE as an actual U.S. national security concern. I'm not sure why nothing has been done about it, and that's not really the reason that I'm here to talk about that issue, but really we do need more localization of these assets if we're going to power the grid that we need so desperately at this point in time. So that's something that HEICO is very focused on being vocal for, and we need customers like you to continue that vocalization and petitioning suppliers to come here and build their businesses in the United States, and companies have. I mean, we're not alone in being a new U.S. supplier. We're excited to be in a great company with a lot of very well-respected companies. Other things that we've responded with to try to overcome some of these market challenges are going to customers early and trying to get them to at least have a conversation about standardization. I'm not sure how many of you have worked with specs that are old, some of them with dates and mimeograph documents still attached to them on your hard drive. It's very hard to get a conversation started with an engineer when you're trying to convince them to change their spec. Sometimes the engineers don't even know why those things are still in the spec, but they know if they take it out, it's probably going to be problematic. So we really tried to engage with them and our engineers on a peer-to-peer level and really allow for some of these standardization conversations to take place and allow us to expedite some of these engineering and sourcing lead times. Again, investing in U.S. capacity, we really need to put our money where our mouth is as a supplier. I'm very hopeful in the next couple of months I'll have some exciting news about our switchgear business as well. But really, we really are trying to build our equipment as much as is possible here in the United States. I know that there's no supplier that sees things that much differently. I am excited to say that we're probably one of the only ones that will be supplying 765 kV transformers domestically. So we did just announce, this was a lot of pomp and circumstance a couple of weeks ago. In addition to our facility, we're going to grow our capacity by 50%. That's a huge investment on the part of the company that just bought a brand new factory to begin with to continue expanding it. And honestly, I don't think it's the only expansion announcement that we're going to have, hopefully. But for this announcement, we upgrade our crane systems. We're adding some new oil processing equipment, expanding our vapor phase, adding an additional shift of work, and adding additional tables for crane stacking. So really focused on making bigger and more large power transformers. We're also going to hire 120 people domestically, adding that to a 400-person staff. That's pretty major for any power transformer manufacturer here in the United States. That's a big headcount. We're also expanding our production capacity by 50%, as I mentioned. Our goal is to become the largest large power transformer manufacturer in the U.S. by 2027. And look, that's an aggressive goal. I really hope that we meet what we're looking for here. But 765, 500 kV, 345, all of those voltages are really what we've tried to tune the factory to be able to build. We were asked to come into ERCOT and present on the scenario of a 345 kV build out for them in the Permian Basin region. This was a big hot topic of conversation. Amongst that conversation was things of cost. How much does a 765 kV run at a certain capacity cost versus 345 kV? And what are some of the other risk factors that we could identify for them to that end? And it's a really interesting conversation. Honestly, in my 20 years, it's the first time we've ever been asked by a system administrator to come in and have such a conversation. Really, these things happen in meeting rooms just like this one, where there's no suppliers present, only the customer base. So this gave a really unique opportunity, I think, for us to have a voice and us to be able to help. So we gave a presentation along with a few other suppliers capable of 765 kV equipment. And I think we really created a collaborative event for them. So we looked at 345 as an option, which was one scenario that ERCOT was considering, and 765 as the other. And we identified some of the key risk factors and did a comparison analysis for it. So that's really what's up here on the board. These are the exact slides that were shared with ERCOT. Really, when we got down to it, and I'll talk about it in a couple more slides, from a cost perspective, 765 and 345 at the same capacity are almost the same exact cost. And the overall capacity that they would realize through installing 765 versus 345 turned out to be their benefit. One of the things that really gave them a lot of oxygen, though, was where they were going to get this equipment, where they were going to access the breakers, where they were going to access the transformers. When you look at 765, there are very few transformer manufacturers capable of it on a global basis. And as such, the demand for things like bushings is pretty constrained. The average lead time for a bushing on a 765 kV transformer is over 2 years. So what we wanted to do was assure them that it would probably wind up being very similar to what we see with growth in things like EV. As there's more competition in the space and more demand for the product, more suppliers come in and lead times go down. So really, we went through it step by step. We analyzed everything from raw materials to things like technology and tariff issues, accessing the market demand timelines, and also some of the lead times for the manufacture of the equipment itself. And really, this was, again, a very collaborative effort. I don't expect that we'll see a similar invitation to such an event anytime soon. I think ERCOT was in a unique position. But I really think that this is the type of conversation that the OEMs need to be having with their end users in a forum basis. Any questions? One of the other products that we make are circuit breakers, as I mentioned before, or GCBs. 800 kV circuit breakers are no different than transformers in terms of their lead time and their cost. Some of the unique things there are pre-insertion resistors, and the access for those resistor materials can be pretty long. What we did with ERCOT in this case was identify some of the costs. 800 kV is roughly 3 times the price of a 362 kV. That actually came from MISO's estimates. The lead time is about 50% longer, depending on the manufacturer. Yes?
Why is the lead time longer?
For 800 kV versus
Yes.
345. A lot of it has to do with the manufacturer's availability, I think, but also some of the components that go into the breaker itself. The pre-insertion resistor materials, lead times for that are not used in some of the other breakers, can be longer to get from the suppliers. But honestly, really for us, once we have those sorts of materials, it's as easy as tuning up our manufacturing output. It's not super difficult to reduce these lead times, and honestly, the prices too. Again, standardization is extremely important. Talking and creating a collaborative environment with the supplier is really a good opportunity to come to consensus on what works in different systems. In the case of ERCOT, most of the time the utilities keep their head down on their own paper and they develop their own specifications. Their output is usually a little bit different than their sister utilities, I think. In this case, AEP, which is the predominant 765 kV user, was willing to share their transformer specifications for the most part with any of the other industrial utilities that were going to be building 765. And just to be clear, for those of you that are not aware of how much we're talking about, the recent release of Permian Basin's project in just by itself, which is one of only about 8 projects, will exceed the current amount of 765 that's already installed in the United States. We're talking about a lot of miles of transmission that's being built. As I was talking about, bushings are a hot topic at 765, and honestly, the industry as a whole is really starved for bushing manufacturers. There's one that is moving to the United States. We wish they were moving to Memphis. They're moving to North Carolina, but they have a symbiosis with Siemens, so that's okay. We just want access to more equipment domestically. Currently, 765 bushing lead times over 110 weeks. We do expect to see, as more and more OEMs come online, that coming down. Tank steel is also an issue, but we're seeing some of the steel suppliers also increasing their output there. We did identify LTCs as an also reliability issue, or at least a lead time issue. And then obviously tariff impact, I think, remains an X factor for pretty much everything that is involved with these projects. Any other questions? Doing that great of a job, awesome. Rising material costs, I don't think that's any secret. That continues to escalate. I think as demand and data center growth continues to go in the same direction, we're going to see the same. Copper price variability is also an issue we identified for copper. We do see that potentially going up by 20% through 2027. as demand rebounds in China, US housing, EV markets. So the bottom line and the takeaways that we provided to ERCOT is that 765 transformers and reactors will benefit from upcoming supplier expansions and will stabilize some of the costs of volatility and availability risks. ERCOT made their decision based on a lot of the information that was provided by the suppliers. I think that's really clutch to this entire conversation. Insulation material supply is increasing as well, which is positive. Radiator supply is set to increase significantly, and this would affect both 345 and 765, reducing some future bottlenecks. Production of HV bushings is expected to continue through 2026. There's some key suppliers that hit some bumps with quality and had some major recalls, which caused artificial inflation of those lead times. That's come down a little bit too. Steel and copper availability is also getting better. But some other vulnerabilities, I think are still X factors that we just don't know about yet. So the bottom line is 765 is good. Any other questions?
How many transformers come out here with this facility?
In a given year, it's about 100. Yeah, sure. That number is planning to increase, but it will be growing not only in the quantity of units, but the capacity, where we'll focus a little bit less on the smaller sizes. Sure.
Besides Texas, where else does the 765 kV exist in America?
So the first project will be ERCOT, which is Texas. The first release within ERCOT was Permian Basin, but there are actually several others that are anticipated. ERCOT is really uniquely positioned because they don't fall under FERC regulations and guidelines, so any of their transmission build-out plans don't have to go through those additional federal approval oversights. So when this was all talked about, we knew that Texas was going to be first, and that's where I think a lot of folks have been focusing their efforts to assist wherever possible. But the other areas are MISO, which is middle of the United States, and that includes several states. Those folks are looking at a bunch of different scenarios, and theirs are slightly more complicated than what ERCOT was even examining. They're looking at a multitude of different voltages. All of them are higher, but the build out will depend on which direction the build out takes place in first. So some areas where they're looking at 765 and 345, one scenario could kind of reduce the obligation for the build out in the other. So there's sort of this frenzy to figure out what's the best solution, and they're all bidding those to their ISOs independently. Additionally, PJM has some 765 kV projects planned as well. One thing I didn't mention was, why HYCO and why 765. That's a really interesting story. So we're a South Korean company. Our headquarters is in Seoul, and for those of you that know anything about the Korean War, South Korea was very much decimated by those wartime activities. Pretty much the entire country was destroyed, and at the time the U.S. was a very strong ally to that country, that government, and as such helped in some of the rebuilding efforts. And so the Korean electrical system actually mirrors the U.S. in many ways. In fact, they use 765 kV and 345 kV exclusively for their transmission voltages. Extremely arduous environment, a lot of mountains, extremely dense population of load centers, very heavily industrialized. Not to mention the country is technically still at war, so security is a concern in whatever they're building. But really, South Korea took 765 and 345 voltages and ran with them, and KEPCO, which is the state utility there, really grew significantly in their knowledge on those topics, and they've even come back in certain cases and helped U.S. utilities design and develop their system plan.
You briefly touched on breakers. What, do you look into different technologies of breakers, or strictly SF6 still, or I think you mentioned air blast, or what other, I know this is more transformer, you just briefly touched on breakers, what other directions are you guys going with that?
Well, I mean, there are only so many directions you can go with ultra-high voltage breakers. We do have an 800 kV breaker offering. It's dead tank. It's a dual interrupter, single neck orientation, which is kind of unique. But it is SF6. You know, the drive to get away from SF6 is strong. And, you know, honestly, it's a pretty rough greenhouse gas. Actually, it's the worst greenhouse gas. It is strong on all the company's parts, right? Everybody's trying to come up with a vacuum or mixed gas opportunity. Really, you know, we're focused on using air wherever possible. But the feasibility of using air alone in a lot of the higher voltage breakers is just not feasible yet. But there is a strong desire for it. Good question. And you know, the other conversation that really seems to be happening a lot, which is a big driver for all of us, is generation. I've talked a lot about transmission and ultra-high voltage transmission products, but really generation is a big need as well. And without the means to get it to the locations where it's going to be used, all the generation efforts are really for naught. But data centers are presenting very new conflicts for a lot of this equipment. Some companies are even looking at using their nuclear power plants to power data centers right at the site, rather than building those data centers out in the field in the middle of the country and, you know, relying on long runs of transmission lines. One thing that I've learned about data centers that I didn't know is how incredibly sensitive they are, and also potentially how volatile they can be to the grid itself. I forget the term that I just learned yesterday, but it was counter-rotational torsion imbalance for generators. And it's not something that I even really had ever heard much about, but apparently these AI data centers are capable of generating harmonics on the system that can actually destroy the generators that are powering them. And I think that everybody is really scrambling to figure out, you know, how do we serve this incredible opportunity, but how do we get a grid that's strong enough and resilient enough to be able to do that. So it's an interesting conversation for an OEM to participate in this kind of triangle between the customer, the generator, and, you know, the end user to figure out, you know, what the solution is going to be. In the case of the NVIDIA servers, which are so popular, I should clarify, it's the AI data centers that are the most volatile. In the case of the NVIDIA servers, there's talk of them, you know, putting some sort of power modulation device on the server itself, which could potentially fix this flicker issue, or really needing hundreds of STATCOMs, you know, practically overnight utility grade STATCOMs to be able to help stabilize this. So it's a very interesting question right now, one that I don't think we've ever seen with our current grid.
To your point, I think the issue is subsynchronous oscillations can break the generation shaft. That's the big concern right now. We're going to talk data centers here in a second, you know, as well. So I'm by no means an expert on that, but that's you know, it's a conversation I was having yesterday in Nashville regarding, you know, issues with AI data centers and the load oscillations that we're seeing and the issues created on the utility system.
Yeah, I'm very interested to hear what you guys have to say on the topic. We you know, are seeing the questions come up from customers, and honestly, we never dreamed we're going to have these issues in places like Oklahoma, you know, which, you know, we don't really think about for AI data center needs, but it's coming, and there are real problems that these clients are going to have to deal with. So again, it's the OEM, the upfront collaboration, all the stuff we can do to help drive those specs, standardize, are going to allow us to reduce the lead time and the cost for the client in the end. Thank you. Appreciate everybody's time.